The uniqueness of Tenmuku lies not only in its iron-rich clay, but also in its unpredictable glaze patterns. The crafting process of Tenmuku has always revolved around the glaze patterns. Without these patterns, Tenmuku would just be an ordinary black glazed cup. Tenmuku's glaze is mainly made from glaze ore and plant ash, which are adjusted together. The potassium and sodium components from the plant ash of gramineous plants can increase the luster and flow of Tenmuku's glaze. This is the best formula for hairs for Tenmuku. Woody plants and legumes, as well as some mixed, other hardwood stove ashes, contain relatively high calcium carbonate content, which can promote the level changes and tension of the glaze phase. Rice straw ash contains tin oxide, suitable for firing oil spot patterns. To prepare the glaze for Tenmuku, we need to ball mill the glaze into a slurry, then filter it for later use. The plant ash is first dried and then fully burned, then ball milled, turning it into smaller particles of carbide. The filtered plant ash is mixed with the glaze slurry. Add water and stir according to a certain proportion to make glaze. Different proportions of the glaze composition result in completely different glaze pattern effects. After this, it is also necessary to apply glaze and a series of special processes to allow the glaze to undergo chemical changes at high temperatures and fuse with the flames, creating fascinating and varied patterns. And these patterns are formed randomly. They cannot be controlled by human power. Let's analyze the glaze of Tenmuku. There are three components in it. The first is the glaze base. Sometimes we hear people say that the vitrification of Tenmuku is very good. The meaning of this vitrification is the layer on the surface of Tenmuku of smooth glass glaze, and the glaze base is the foundation for firing this glass-like texture. Its main component is quartz, containing a certain amount of iron oxide ore. The second is the colorant. Iron oxide is the colorant. For example, copper oxide is green. Cobalt oxide gives it a blue color. As for black glaze, it primarily uses iron oxide as the colorant. However, when the iron content in the glaze reaches 8% to 10%, the fired glaze turns black. The third element is the flux. For example, feldspar, talc, and wood ash. Limestone, actually, is a kind of natural alkali. These can help reduce the melting point of quartz, saving a lot of fuel and time. It also solves the problem of high iron clay not being able to withstand high temperatures. Tenmuku must have an iron body, and the raw materials and firing process have many uncertain factors. Among them, the glaze is a very important part. Tenmuku are glazed once and fired once, and a thick glaze must be applied. The glaze greatly restricts the success of Tenmuku firing. If the glaze is thick, the drying shrinkage is large, and the glaze layer is prone to cracking. It doesn't adhere well to the body. It is particularly prone to glaze crawling during firing, or glaze peeling. Tenmuku are fired at a high temperature of about 1300 degrees Celsius. At this time, the viscosity of the glaze decreases, and it will flow downwards. If the glaze keeps flowing down, the glaze layer will become thicker and thicker, and the rim will become thinner and thinner, leading to uneven glaze thickness. This has a great impact on the formation of the patterns. If the glaze layer is too thick, the firing temperature is too high, or the firing time is too long, the glaze will flow to the bottom of the cup, causing sticking to the bottom. Sticking to the bottom is considered a defect. Therefore, every Tenmuku undergoes many difficulties to be born, containing the hard work and sweat, condensing infinite expectations,